So for the first passage, we're going to do the first 7 questions. In passage 1, we're back to data representation. So the passage is going to be taking us through reading, tables, charts, and graphs. So you don't need to take the quiz independently today. You can just follow along directly with the lesson. So, first things first, always, is go to the question. So, according to figure 1, so my locator is figure 1, how would the colonization of an artificial pond be best characterized at 14 months? So I'm going to go to figure 1, I'm going to find artificial pond, and I'm going to look at 14 months. So that question is like pretty straightforward. It lays it out for me. So I'm going to go to 14 months. So I know that. Colonization of artificial ponds. Okay, so these are all artificial ponds. So at 14 months, I'm going to have, let's see, it looks like I have this thingy, a lily pad, a tree, and humans. So, I have adult amphibians, I have whitewater lilies, I have pond scum, I have spike rush, 2, 3, 4, 5, and I have zooplankton. So I have pond scum, zooplankton, lilies, spike rush, and adult amphibians. Pond scum, zooplankton, lily, adult amphibians, there's a spike rush. Okay. A mixture of aquatic plants and adult amphibians. The pond would contain a mixture of algae, aquatic plants, and amphibian larvae. The pond would contain a mixture of algae, aquatic plants, and adult amphibians. Well, I know it has adult amphibians because I remember that from what I underlined. So I'm going to cross off A because it doesn't say that. This one says adult. This one says adult. So now, do I have plants? Yeah. I had white water lilies and I had spike rush, so I'm going to say those are plants. So I have aquatic plants, no, aquatic plants, it's not D. So now I need to decide between B and C. So mixture of algae, aquatic plants, and adult amphibians. Let's figure out what these things are. And so now I'm going to go back here. Plant life, plant larvae, microorganisms. Okay, well, these two things, right, pond scum and zooplankton, those are going to be my microorganisms, or algae. So, my answer is C. Alright, number 2. Given the information in figure 3, so my locator in your head, you should be saying figure 3. The greatest numbers of long-toed salamanders can be found in artificial ponds that. So I'm going to go to figure 3 and I'm going to learn all I can about long-toed salamanders. So I found figure 3. I'm going to go to my long-toed salamanders. Now, do I want the highest number? Is that what it says? The greatest numbers of long-term salamanders. Long-toed, my bad. So right here, and right here. There's all 4 dots in there. So that is 2,000 square meter pond. That is 0.5 meters deep and 1,500 meters to water. So I find the most salamanders in a 2,000 square meter pond that is 0.5 meters deep and 1,500 meters to water. So 1,500 meters to water, 1 meter deep, no, surface area of 1,000. Surface area of 2,000, surface area of 2,000, oh, that says greater than, nope. I can cross off H because that says greater than, so the greater than takes my 2,000 away. Greater than is an X, it's not what we want. So, 1,500 meters from the water, yep, so I can cross off H and I can cross off F because that number's wrong. So I should have 1,500 and 2,000, so I'm between G and J. And now the depth, 1 meter is not what we wanted 0.5. J is the only one that hits all the targets. Alright, number 3, the passage, that's actually my locator, defines colonization of an artificial pond as. So remember how I said if it doesn't tell you where to look, but it does say passage, it's probably going to be in the blurb, like literally right under the word passage. That's where we at. So, the natural process of colonization of an artificial pond with microorganisms, aquatic plant life, and amphibian and grown amphibians over time. So we are documenting colonization. So what do we define colonization as? The natural process by which algae, plant life, adult amphibians, and larvae appear in an artificial pond. That one sounds pretty good to me. Answer choice A. Looks like it hits all the buckets, but I'm going to read on. The introduction by man. Let's see. Natural process. So nope, not B. I can immediately cross that off. Natural introduction by man. I can cross that off. So I'm between A and C. Of predators, literally didn't mention that, not at all. By, the answer is A. All right, number 4. The scientists estimated the number of amphibian larvae present in each artificial pond by. I don't know. Let's find out. Okay. So, as colonization progresses, amphibian larvae gradually displace vegetative cover. The larvae populations were estimated by trapping and counting the number of larvae in 1 meter cubed of pond water at the edge of the pond and multiplying this number by the circumference of the pond in meters. So what did scientists do? Trap and counted 1 cubic meter. Cool. Multiplying it by the surface area. No, we want 1 cubic meter, and then we want the circumference. I'm not going to write the whole road because that's going to take forever. Whatever. Fine, I'll write it. Okay. Trapping and counting in 1 cubic meter circumference. Cool. Trapping and counting in 1 cubic meter, then multiplying by the circumference. Cool. 1 cubic meter, and multiplying by the surface area. No. So I can cross those off because we didn't measure the surface area. Now, which one is it? Is it cubic meter of edge or cubic meter of central? Let's go back. We have the cubic meter of edge. So the answer is G. Cool. All right. Almost done. Number 5 says, number 5. According to the information that depicts change in percent vegetative cover and the change in amphibian larvae population as time passes after the 12th month. What happens? This is a trend question. So it's all words, but it's actually IOD. So I'm going to go to the 12th month in this passage. 12. And it looks like my larvae would be Pacific. The little tadpoles and the larvae would be here. That's what I would put. So like this is larva, and then my tadpoles and Pacific tree frogs are baby. They're not adults yet. So it looks like after the 12th month, what's going on here? The number of larvae is going to increase because it's actually showing up. But now what are we comparing it to? 5. So, according to the information that depicts the change in percent vegetative cover and the change in amphibian larvae population as time passes. I bet you this is actually one of these other figures because that graph is super visual. Age of pond, number of tadpoles, percent vegetative. It is this graph. Great. So, notice it did not give me a locator, so it didn't say figure 2. We had to find it. And I was looking at the wrong thing. So we actually have to find it. So, as the pond increases, so the number of larvae increases as the vegetative cover decreases. So I just traced that graph. So the number of larvae increases, vegetative cover decreases. Yeah, that's literally exactly what happened. For this one, because it's a black and white answer, you don't actually have to read basically anything. Alright, on the basis of the data presented in Figure 1, so now we do have a locator. Figure 1 is our locator. Which of the following conclusions concerning colonization is correct? Colonization usually begins in winter. What? I'm going to cross that off right now because it doesn't even say that. It doesn't say the season. It says the number of months. So no season, just months. The final state of colonization is characterized by the presence of only plant life in the pond. Also no, if you look at the picture, there were like frogs everywhere, right? So frogs plus tadpoles. So no, that's not only plants. Colonization of an artificial pond is characterized by an increasing diversity of plant and animal species. That maybe. As colonization progresses, there is a decrease in the diversity of plant and animal species. So this mentions diversity. On a common sense whim, like without even looking at this, the answer is H. One, because it's more scientifically specific, and then we can go back and confirm our answer. Like, what's happening here? As we got bigger, look at how many things we had. So we started with just pond scum, and now we have all of this. So that's going to be an increase in the diversity, not a decrease. Also, a way to note that, even without really understanding the graph, when we look at a graph, we usually look at the graph from left to right, and from left to right, this is going up. That should show you that something is increasing, even though it doesn't look like a normal graph because it's a table. All right, 7. According to the information in figure 3, so that's where I'm going to go, the number of Pacific tree frogs. Let's find out. So, what happens here? If I look at my Pacific tree frogs, as you get closer to the water, you have increase then decrease. As you go deeper, it decreases. And as the pond gets bigger, it increases. But actually, this is like stays the same and then decrease. So this is increase, decrease. This is same, then drop. And this is increase. So now we just need to do our answer choices. So distance to nearest water body is increase, decrease. Pond depth is same and then drop. And pond surface is increase. So now I'm back to this question. Stays constant as pond surface area increases. We know that's wrong. That was my increase one. Decreases as pond surface area increases. No, because it literally went up. Increases as pond surface area decreases. No. And increases as it increases. Yep, this is a positive correlation. All right, that is passage 5.1.